In this video, we're going to talk about the maximum subarray problem, which is a great example of divide and conquer algorithms. Let's get started. So consider the following chart. So you can suppose, or you can interpret this as a stock market chart, and these are the prices of a certain stock. And what we want to do is we want to buy that stock when it's low and sell it when it's high to maximize our profit. And suppose we have a 17-day window as shown to buy and sell. So we could buy here. Oops, I'm going to do that. Let's go here. Okay, so we could buy here and sell here, and that would give us a profit of, well, we'd buy at about $85 a share and sell at $105 a share. So that'd be about a profit of $20. So what we want to do per share. And so what we want to do is we want to find where we can buy and where we can sell to maximize our profits. Now, a logical way of thinking about it is, well, let's look at the lowest share price, and the highest share price. Buy at the lowest, sell at the highest. Well, we can't really do that in this graph because the highest share price is before the lowest share price. But what we can do is we can buy at the lowest and then sell at the highest that comes after the lowest, right? And so that right there would give us a profit of, what, from 65 to 105, so of about $40 per share. What we can then do is we can look at the highest share price, which is here, and go left until we find the lowest point there. And if we buy and sell at those points, we would make about $15 a share. And so, right, the $40 profit would be what we want to do. That might be a logical way of thinking about it, but consider this chart. If we start at the lowest and go right to the highest, well, there's no profit. We've gone out of the window. So let's start at the highest and go left to the lowest. And there we make $1 in profit per share. But it's fairly clear that what we really want to do is we want to buy here on day 2 and sell on day 3, which would give us a profit of $3 per share. So this is an interesting problem in that the brute force way of solving this problem. So to do it brute force, what we would want to do is test every pair of of dates or of data points. Now, how many pairs of dates are there? Well, we haven't really talked about this, but it's n choose 2. So you have n dates or n elements, and we want to find how many pairs that we have. It's n choose 2, which is defined to be n factorial divided by 2 factorial times n minus 2 factorial. And so we have n factorial equals n times n minus 1 times n minus 2 factorial all over 2, which is 2 factorial, times n minus 2 factorial. Those cancel out, and we end up with n squared minus n over 2, which is big theta n squared. So it's an n squared algorithm to test every pair of dates. The question is, can we do better? And of course the answer is yes. Instead of looking at the actual values, we want to consider the table of changes. in function value. Now let's scroll up and look at our original chart, and here, right here in this table, we have the price, but then we also have the change in price. So right here we see that the price increased by $13 a share. But in the next day, it decreased by $3 a share. So it went from 113 to 110. So here we see all the differences in the price for that day. And that's the data set we're going to be dealing with. Now to compute that array, it's going to be order n. We have to look at every element in the array one by one. But this we can do. Okay. So this is the max subarray problem. I want to find in an array the contiguous subarray that maximizes the sum. So in other words, if I added one more element, if I added that element there and found that max subarray, then this sum would be less than the max sum. The approach we're going to take is the following. This figure shows what we're going to do. We know that the max subarray is either going to be entirely in the lower half of the array, or it's going to be entirely in the upper half of the array, or it's going to cross the midpoint. Now that's kind of a duh moment, right? But it's going to be one of those three things. What we're going to do is we're first going to consider finding the maximum subarray that crosses the midpoint. And it turns out that that's reasonably easy. Then we're going to find the maximum subarray in the lower half and the one in the upper half, and then we'll compare the three of them and use the one that gives the maximum sum. And we'll start with the details in the next video.